Today I am going to discuss about electrostatic and it based on the electric charges. Electrostatic is the branch of physics which describes about the static charges or charges at rest in any material like conducting material. For example, we can take a glass rod and we rubbed with the glass rod with the silk. Then if you you get one glass rod with another rubbed glass rod in close means the both glass rods will get reflex because both are gets positively charged. If you take one ebonite rod, you rub it with fur and another ebonite rod rubbed with burr and you get closed. Both of the rod you get closed means it also gets reflected because both are gets negatively charged. There are two charges here, one positively charged electric charge and one negatively charged electric charge. So we simply describe one glass rod with the positive charges and another glass rod with the positive charges means get repulsion each other. And in another material, one glass rod with positively charged and another another ebonite rod with negative charge close together means it gets attracted. So from this we conclude there are two types of charges, one positively electric charge and another one is negatively electric charge. Based on these things, one scientist named Coulomb defined one law, that is Coulomb's law, that is called Coulomb's law. So now I explain Coulomb's law. So consider 2 point charges, electric charges. One is Q1 and particular distance, another one electric charge, consider that is Q2 and the distance between them. You just consider this R. Okay. So Coulomb's law describes about that these Q1 charge and this Q2 charge both are have some energy, some forces. So the forces between these two charges, I mean he explained about these two charges, the forces between these two charges he explained. So now we explain that the force between these two charges is directly proportional to product of the two charges, product of these two charges, that is q1 q2, and inversely proportional to the square of the distance between them. So here you just imagine that q1 is and q2 you get if the q1 and q2 both are have the same energy means they gets repulsed. Okay, if q1 is positive or q2 is negative means it gets attracted. So if the distance increases means the force will be less. Distance is less means the force will be high. So only he describes the force between these two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So this is called Coulomb's law. So why it is named named as Coulomb's law? Because the Coulomb, the scientist, described this. So only they put their name to this law. Okay. From this, we derive one small sum. Okay. So consider this Q1 have 1 Coulomb force and this Q2 have 1 Coulomb force. So the distance between them are, you consider 1 meter. If it is means 1 meter, then it will be 1 into 1 divided by 1 square, which is f that is directly proportional to 1. But here the directly proportional, this proportional have one constant value, that is we put k into 1. The k value is equal to 1 by 4 by epsilon naught. So now from this constant, k constant, we can derive the force. How much force from these two charges arrive? Means we explain from this 1 by 4 by epsilon. So here epsilon is the relative permittivity in free space. It has the value 8.85 into 10 to the power minus 12 Newton, Coulomb square per Newton meter square. Okay. So now the sum will be, so the total 1 by 4 by epsilon naught. The total value of this 1 by 4 by epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per Coulomb. Okay. So the force will be F equal to 9 into 10 to the power 9 Newton meter square per coulomb. Okay. So the force between Q1 and Q2 charge is equal to 910 to the power 9. So this much of this amount of force arrived from these two charges. Okay. From this we conclude with the Coulomb's law. The Coulomb's law says that how much of the force between two charges we have